everyone. Today I'm actually really happy because I passed my first round with Pony AI, and I'm thinking to set up my final round about 2 weeks later. But that's all that, and I'm going to do a bunch of tree problems just to get me familiar with manipulating those pointers. Today we're going to look at problem 510 in order successor in binary search tree 2. And there's actually an in order successor in binary search tree 1, which I also plan to make a video, but since I haven't done this one, so let's get started. So we are given a node in a binary search tree, and we want to return its in order successor of that node in the binary search tree. And if that node have no in order successor, it should just return null. So the definition of in order successor is that if we do a in order traversal, it's the node right after this node. For example, if for this tree, the in order traversal will give us 1, 2, 3. If we're given node 1, the node after that will be 2. And in this example, the in order traversal will give us 1, 2, 3, 4, 5, 6. If we're given a node 6, we'll find out this is already the rightmost node, so it will return a null pointer. Let's look at another example. In this tree, the in order traversal is 2, 3, 4, 6, blah, blah, and we're given node 15. So the in order traversal will be, if it does have a right child, it will be the leftmost node of the right child, of the right subtree. 13, so it will be 15. So there are two cases. Case 1, if we have a right subtree, then we need to find the leftmost node of right subtree. Case 2 is if we don't have a right subtree, for example 13 here, we need to find its parent node such that this node is not its right child. Need to find a parent node such that the node is the left child. Okay, cool. And the time complexity for this would actually be O log n, where n is the height of the binary subtree, and the space complexity will just be O1, since we're just manipulating these pointers and retrieve information. Within that, I guess we can get started with the coding. So if not node, otherwise, if we do have a right pointer, then I will just return find leftmost node. Else, we return find first parent. Node. Okay. Now let's actually define those two helper functions. Node right. Cool. So the first one is we still need to return a node, and to find the leftmost, we just do if it still have a left node, we just make it equals to left left, and then at the end I'll return node. Another helper function is find first parent. Node pointer node. In order to find the parent, we can do while node parent still have value, and if this node is the right child. I should go one level up. Only after, for example, if 13, we did find its parent, but we found that the 13 is the right side of this node. That's not going to be our successor. We have to go one level up, and we find this is again lies on the right hand side. It's not their successor either, so we have to go one level up. Then we find that the whole part is on the left side. Then this 15 is going to be our successor of the 13. And at the end, I actually should return node parent. Cool. Let's try and run the, and I think that's pretty much it. Let's submit it. Perfect. Cool. I will also do, so this scheme not only work for binary search trees, it also work for binary trees. I'll also do the first problem of in-order successor in binary search tree, which basically have the same time complexity and space complexity, but instead of we are given a parent pointer, we're given the root of the tree. But the whole framework is the same. We have two different cases, and for the first case is exactly the same. For the second case, instead of going from the parent, we actually can start from the root. But yeah, I will make those videos and stay tuned.